is limited for a very interesting presentation, so I suggest we start. So welcome everyone. I am Jozefien Vanbecelaere, Head of EU Affairs at the European Heat Pump Association, and I will moderate this interesting webinar today on digitalization in the heating and cooling industry. This online seminar is organized by the European Heat Pump Association under the umbrella of the EU Industry Week. So this year, the EU Industry Week is organized in different teams, and we fall under the team Shaping Europe's Digital Future. It's also organized with the support of the Heat for Cool project. So that's a project in which EHPA is involved and which focuses on the integration of advanced technologies for heating and cooling, both at buildings and district level. And we will hear a more extensive presentation on this project later today. It's also organized with the support of a study assigned to EHPA by the European Commission DG Enner, and this study is titled The Overview of Heating and Cooling, Perceptions, Markets and Regulatory Frameworks for Decarbonization. You can find more information about all these projects on our website, ehpa.org. So why are we here today? Well, we know that the use of computers, digitalization in general, has transformed many sectors and industry, and is now also arriving at the heating and the heat pump sector in specific. So heat pumps have been equipped with microcontrollers from the beginning, but only now these start to connect and to interact with the outside, with the internet, with other devices and the electricity grid in general. This enables heat pumps to be more efficient and more flexible. It enables them to be a controllable load in an electric grid that is more and more shifting to a world where the supply needs to follow the demand from the varying renewable sources. So by combining supply and demand data, a more efficient and convenient provision of heating and cooling can be enabled. And this serves to improve grid stabilization. So flexibility, reliability, and comfort, these are all services that make the use of heat pumps economically more attractive and also increase the comfort for the users. So digitalizing this sector should make heat pumps more attractive from the economic perspective, from the comfort perspective, both for the system and for the users. And the importance of digitalization is also recognized at EU level. Specifically, we have seen in the EU strategy for energy system integration that was published in July 2020, that digitalization is a key aspect for system integration. And the Commission is working on a digitalization of energy action plans. So also in the industrial strategy, digitalization is a very important aspect. So the importance is clearly increasing. Today's online seminar, we will get an overview of the state of the art of digitalization and flexibility, but we know that we are not yet there. So we will also look at what are still the barriers, what are the challenges today, and what are the next steps to fully unlock the potential of this digitalization. In the first half hour, as you can see on the slide, we will focus on the policy side, a more broader perspective, more high level. And then in the second 1 hour and a half, we will look at different research and innovation projects on digitalization. So we have both perspectives and we will try to combine them. Let's start with our first two speakers. So our first speaker is Lindsay Sugden. She's head of heat research at Delta E. She's a heat expert with 14 years of experience, and she leads Delta E's heat research team. So she supports heating manufacturers, energy companies, policymakers, and other stakeholders to capture market opportunities in the heating sector. So Lindsay will tell us more about how electric HVAC is enabling demand-side flexibility today and what is the potential. So Lindsay, please, you have the floor.
Thanks, Jozefien. So I'll just share my screen. Okay. So So I'm just going to minimize that. Yes, so thanks very much for the introduction, and thank you for having me. As Jozefien said, I'm from Delta EE, and just a really brief introduction to who we are. We're a research and consulting company helping organizations to navigate the energy transition, develop the best strategies and business models for the energy transition. And we work across these different areas of the new energy market. Heat is in the center. We've also got a lot of work around flexibility. We help our clients through subscription services and bespoke consultancy. And yeah, as Jozefien said, our main clients in this area are manufacturers, energy suppliers, network companies, and policymakers. So in this presentation, I'm just going to pull out a few highlights of some of the work that we've done around the heat and the flexibility space to understand what the flexibility market looks like for heat. So first of all, to look at how flexible electric heating can create value, and it does this at different levels. So at the first level, what we would call home values, where the main value comes through end user running cost savings, and there you have self-consumption optimization. So for example, heat pumps and PV, time of use optimization, where heat pump operating times might be shifted according to time of use tariffs, so that they run at the cheapest times. The main value here is going to the end user in terms of running cost savings. The other group of values is electricity system values. And the main value here is profiting from selling services and trading flexibility. So this isn't necessarily coming directly to end users, but rather to service providers who may share some of that value with the end users. And there are many different value streams within this, but the main types of value which are being used at the moment in the residential heating sector are around ancillary service and trading in the wholesale markets. Most of the activity we see today, if you think about heat pump manufacturers or electric heating companies, it's around this time of use optimization and self-consumption optimization. But there are more examples emerging of HVAC companies getting involved in projects and some commercial offerings around the electricity market values. So we've done a scan of what the market looks like in Europe today in terms of what is the potential flexible capacity and how much is actually being used at the moment. So if you look at the installed base of electric heating and hot water assets across Europe, at the moment, it's around this level. You can see that the heating and hot water part is the vast majority of this potential flexibility when you compare it to, for example, EV charge points, which perhaps gets a bit more press and marketing. That's actually a small part of the installed base. However, only a very small share of the potential capacity is actually being used in flexibility at the moment. And it's being used in these two ways, which I just mentioned. So which types of assets are being used? So in this around 1.4 gigawatts of installed flexible capacity, which is actually being used for flexibility today, the biggest share is actually for direct electric space heating, which may not be what you would expect, but this is dominated by the success of one particular player in France, Voltalis, who are controlling a huge asset base of direct electric heaters. Hot water tanks and hydronic heat pumps are the next two important areas. Hot water tanks are increasingly being recognized as being able to offer a lot of flexibility, and hydronic heat pumps are growing the fastest. Built-in connectivity is becoming a must-have really for manufacturers. I think moving towards the future, we expect to see a more varied range of technologies and solutions offering flexibility. So you've got emerging heat battery technologies, electric dry core storage boilers, for example, new generation smarter storage heaters, air-to-air heat pumps, a lot of other asset types we expect to see being more important in the future. When we look across the European market, in terms of where is the most activity, France has by far the largest market. Again, this is related to the success of one particular player. And then there's the Nordics, Germany, Netherlands, Austria, Switzerland, and the UK. There's reasonable amounts of activity. When we look at what's driving the success and what are perhaps the success factors across these markets, one key thing is the availability of multiple demand and response value streams. So in France, the UK, and Finland, these markets are relatively open, and there's several different value streams open to demand response or demand side flexibility, which makes them positive markets. In some markets, particularly in the Nordics, you have obligation on energy suppliers to offer variable electricity tariffs. And while there are these kinds of time of use tariffs emerging in other markets where there is a regulation that energy companies have to do this, this is also a driver. A large installed base of electric heating is obviously a useful driver. And then across Europe, we're seeing a lot of the activity being driven by new entrants and innovation in products and services from not just the heating and energy space, but coming from IT controls companies, aggregators. So it's not all driven by the big energy companies, you could say. So just in terms of a brief introduction, that was my slides, and I'm looking forward to the discussion afterwards.
Thank you very much, Lindsay. This was very interesting. We will immediately go to our next speaker, and we will discuss after we have heard both presentations. So our next speaker is Atzin Madrid. She's product manager at Equiwatt. Equiwatt is a clean energy tech startup pioneering in residential demand side response in the UK. So it is an IoT and artificial intelligence smart energy platform and app that rewards households for consuming energy wisely and also according to the grid needs. Atzin herself, she specializes in energy system innovation, in demand side response and electricity markets. She participated in research on new flexibility methods, innovative business models, and technologies. So please, Atzin, go ahead. The floor is yours.
Thank you, Jozefien, and thank you for the invitation to participate in this event. Yeah, so as a bit of context, and trying not to delve too much into it because, lack of time, and given that we're all familiar with the role of low carbon technologies and the challenges that we face to deploying them, the thing that I would point out as a scene setter is that heat pumps in the UK are not at the level that they should be. And the current proposition is not appealing enough for the mass market due to various reasons that we can discuss further in the discussion, that we are probably very familiar with the upfront costs, high bills concern, that they could be potentially bulky and noisy, some of the tax levies, market distortion, etc. And that's one big issue, but also the other issues, the disruption that they will cause in the electricity networks once these technologies are fully embraced and scaled up. And so we need to transform our energy system, and we need, for that, we need innovative solutions. So why DSR? Residential demand side response, and demand side response, for those who are not that familiar with the term, is when consumers adjust their energy usage in response to an external signal, And RDSR is considered to have the potential to help create the smarter and more flexible energy system to achieve net zero targets. And it is actually proving its commercial feasibility and the benefits for consumers and for all stakeholders increasingly. Why? Because it generates additional savings and cost reductions to existing projects and technology such as heat pumps. And it also can increase the appeal of heat pumps for the mass market rollout for all consumer archetypes and not only for early adopters, which is the case that there's a niche segment that they're selling them now. By rewarding user behaviors, and I'm going to talk a bit more about this in the next slides. But also at the same time, it provides a solution to reduce the impact of domestic.
Atzin, I think you forgot to share your slides. We don't see any slides in any case.
Oh, I'm sorry.
Okay.
Sorry, thank you. Thank you for pointing that out. Do let me know if you can't see them.
Yes, if you could just.
Okay. Yeah, I'm going into full screen mode.
Perfect, thank you.
Yeah, thank you. I'm sorry about that. Yeah, so yeah, they also provide a solution to reduce the impact that domestic heat electrification, the stress it will cause on the electricity networks to balance the grid in a cheaper, less carbon intensive way, and also to enable a better network planning and operation by managing local networks and constraints more efficiently. So through engaging and connected digital technology, we can revolutionize the way that homes collectively use energy. And that's what Equiwatt has been doing for the last few years, unlocking residential demand-side response by engaging consumers and rewarding action. And this is enabled by our community-powered virtual power plant. And basically through our platform, what we do is that our platform helps homes to save energy and consume energy wisely, most particularly to cut their energy use at peak times. And then we also are that platform to energy companies to reward households and users for those actions. And then that can that becomes benefits and asset for energy companies, mainly in reducing the use of dirty and expensive peak time energy, to improve margins, to generate cost savings in operations and consumer service, and so on. So that's very important. To enable this, the consumer engagement bit is very important and hasn't quite been cracked yet. And the consumer needs to be put at the center of this. So we target human motivation. So we know through experience and different research that householders want to do more for the planet. People want to do more, we want to do more, but it's hard because we don't always have the time, we don't have the resources or the understanding to do so, to understand, to engage in energy saving activities. So what we have done is that we have simplified this. We've made it very easy for householders to consume energy wisely and to cut their energy at peak times through an app that was designed to make energy saving very fun, rewarding, and impactful. So the benefits for the user are very tangible. So they can see it in energy bill savings, in rewards every time they participate in these saving events that they can then cash out for vouchers. And it's basically rewarding for doing their bit for their planet. And ultimately, they can also reduce their carbon footprint. So through a system of automation, rewards, gamification, and community, we're delivering a scalable and commercially viable solution. And this is a bit of how our architecture works and our platform works. So households engage with our app, and our cloud software identifies these RDSR actions, and then manages peak time energy events by aggregating household IoT. And currently, the automation and control of these internet-enabled home devices in our proposition is through smart plugs. But our platform is built to integrate with a wide range of smart appliances, EVs, smart thermostats, and obviously heat pumps, which is where we are currently in an early stage trials of our smart heat solution. And basically this diagram hopefully shows you the architecture of the integration of our solution, which is through integrating to our cloud. Heat pumps are digitally enabled and integrated into our digital platform. And this allows interoperability between the devices, which in a nutshell allows the smart management of the heat pumps and to be smart grid ready, to respond to RDSR signals and energy saving events, which we call eco events. And basically there are three core elements there: the automation, comfort, and control, which are going to be key elements to get their balance right for people to embrace this kind of solutions. And just to exemplify the previously mentioned, I wanted to put this as a case study, a demonstrator on which we are working with the local council to reduce peak energy consumption from air source and ground source heat pumps in households, from demand side response services and smart heat pump management. And essentially what we are looking to see in real life in environment and conditions is to unlock additional energy savings, to reducing CO2 emissions, to enabling electricity bill saving potential beyond the heat pump, what the heat pump can already provide, unlocking revenue, potential revenue from DSR income, from the different flexibility markets like the balancing markets. And this overall can reduce the whole project payback period. And these numbers are just an estimated potential scenario values based on air source heat pump, and I'm happy to also discuss a bit further about them. They're just pilot numbers and estimations. And yeah, just to finish, these technologies are helping contribute to whole system transformation for network operators, for households. Now that we are facing a post-pandemic scenario that we need to deploy green employment, low carbon employment, and ensuring clean and affordable and reliable energy for all. That's what this is allowing, and hopefully we can pave the way towards that. Thank you.
Thank you very much, Atzin. So I see that there's a question from the audience, first of all, for Lindsay, on why Italy is not included in your study.
Yeah, we have looked at Italy. It wasn't one of the markets with the most activity in terms of residential flexibility, but if the person who asked the question wants to send me an email, we can happily discuss it separately. But it wasn't one of the chosen target markets in that study, because there wasn't so much going on, but it doesn't mean there's nothing happening. So yeah, it wasn't a comprehensive study of every market. So.
Okay, thank you. Then there's a question also from Franz Tack. What mechanism can save energy in this case? I'm not really sure what he is pointing at. I guess it's for the presentation of Atzin. Atzin, do you have an idea what he would mean with the question?
No, I think if it can be a bit more specific, then maybe.
DSEM, I mean, he says.
Demand side energy management.
Yes.
Yeah, I suppose. So, I mean, this is essentially an RDSR platform that's driven by IoT and AI. So basically, operating by actioning external signals, from carbon intensity, energy prices, etc., and then we turn those signals into actionable. Into actions from the users that use our platform to essentially manage their peak time consumption, switch off, switch on, and essentially delivering flexibility.
Okay, thank you. Maybe you can engage further in the chat on the questions, because we have limited time and I would like to ask you some other questions as well. First of all, I want to go back to Lindsay's presentation, because you mentioned that in the Nordics, there's an obligation on energy suppliers to offer variable electricity tariffs. But yeah, if I'm not mistaken, the Electricity Market Design Directive actually obliges all member states to implement this, to offer variable electricity tariffs. So does this mean that this has only been implemented so far in the Nordics, or how do you see this?
Yeah, it's a process. So it's already been in place in Sweden, I think, since 2017, Denmark since last year. So it's, yeah, in the end, this is where all the markets will have to go, but they're not all there yet. But yeah, you're right, it is in the plan, but it makes a difference. You can see that where that has been the case for a longer time, there's more companies that are offering, you know, innovative time of use tariffs and so on. So, but I mean, there are also these tariffs emerging in markets where it's not regulated yet. So in the UK, for example, like Octopus Agile tariff is quite an interesting one. So it's still happening, but where it's being regulated, there's many more players getting involved. So that's the key point.
Okay, so that's very promising. So we hope all member states implement this very soon. Then I have a question for Atzin. So you are offering demand-side flexibility solutions in the UK, and you say that now you start using heat pumps for this. So that this is, yeah, if I read also on your website that you started with, yeah, devices that people have standard in their house, I would say, not, for example, an EV or a heat pump or PV, but now you are also using these appliances, I would say. How was it to connect to the heat pump industry? Did you find the right sparring partners in the heat pump industry? Can you elaborate a bit more on that?
Yeah, sure. Yeah, so just elaborating a bit more on that. As I mentioned in the presentation, our current proposition, what's available for users at the moment, and you can actually join to the platform, is through Smart Block. So basically, this enables any appliances, any dumb appliances in homes like fridges and freezers, electric heaters, and so on, to connect to our platform and then participating in energy saving events. But our heating and EV charging solutions, as you will mention, they are being currently developed. We have some early stage proof of concepts that we have trialed. And in terms of partners, I'd say that we are working mainly with local councils and universities, exploring through houses and investigating this together. But it is, I think it is very important to differentiate or to highlight that this is still very early stage. It hasn't reached the scalable point yet. And there's definitely interest and there's an appetite. There's a win-win for everyone. And I think the marketplace are seeing it, because UK is becoming a great place for RDSR, and it's been slowly unlocking. But so, stakeholders have like good interest in developing, because, heat pumps load aggregation present a significant opportunity, as it's higher than traditional appliances and they meet the requirements for DSR services. So all the elements are there essentially, but it's just a matter of time and how to make this happen. And not every player in the market is that innovative, and we need to find the right partners who are willing to take that early stage risk. And it's basically about that, about de-risking this, which is still the issue to scale and go commercially big.
Okay, so maybe this is could be a call to manufacturers or other partners that see interested in this to contact you to start cooperating.
Yes, yeah, I would love to explore partnerships for sure.
Okay, so a more broader question for both of you. So we see that heat pumps are smart grid ready, but it seems that, yeah, from a few offerings in the UK and Scandinavia, most grids are not smart heat pump ready. So why do you think utilities are not yet offering more services to end users and the industry at this moment? Maybe Lindsay first.
Yeah. Yeah, I think there's three different points I could make there. Firstly, there are still barriers to entry. So the electricity market is not always open for small, particularly for small decentralized assets, like for example, heat pumps in homes. There in some of the markets, for example, there's minimum bid sizes or limitations on using aggregated loads. So some of those regulations make it more difficult. And the electricity market's not always open for all different types of players. So new energy suppliers or aggregators can't always easily get access to the market or be able to engage with directly with customers. And it's kind of reserved for the bigger players, which is also a challenge. A second point is the right kind of infrastructure in place. So obviously the smart meter rollout is happening, but it's not 100% across every country. So that also is a limitation. And then a final point: are there enough kind of incentives or carrots and sticks, if you like, for suppliers and for customers to engage in this market? So we talked about in the Nordic markets, the regulations kind of make the suppliers have to offer hourly or half hourly pricing. But the other question is the market value enough to make this make sense? So the amount of money that can come back to the end user, it's more in the range of kind of tens of euros rather than hundreds of euros. And if you add to that often in these projects there's additional hardware and controls and so on being added onto existing systems, which can run up to hundreds of euros. The financial benefit to the customer is not always clear. So if the energy companies or the utilities can't see what the value is, it's difficult for them to sell it to end users. But having said that, there's a lot of innovative new energy companies emerging who are active in this space. So yeah, a few names like Tibber, Awatar, ST1 in Norway, Awatar is in Austria, Germany. There are companies who are engaging, but they're not so much the big incumbents.
Yeah.
So yeah.
I'd say that I think that was spot on. We completely agree with that, and that's obviously on the incentives of the market, and that it has to make sense commercially for utilities, which it doesn't quite yet. And as we mentioned earlier, there's the appetite for this. We know that many utilities are exploring heat as a service option, but again, it's early stage, and it's about also heat pumps are not that accessible yet. The number remains very low for it to provide like a significant a business case. But also something that I wanted to point out is that we're not sure we could say that heat pumps are smart grid ready per se, because yes, in the sense that to the extent that brands that we are aware of, they have the smart control feature, but to be smart for the grid and to be smart grid ready, it has to enable to be managed by a centric point, by a manager, which needs to be internet enabled, essentially. And we have found that in the UK, you can install a heat pump without internet. So for instance, it's like in the EV's case, like there's been more regulation towards making charging smart. So you can, unlock this whole interoperability and data gathering and all these different benefits for the end users and for the market itself. But in the case of heat pumps, you can actually install them without them being internet ready. So we don't think there's a mandate, that heat pumps should be installed to be internet enabled and smart ready yet, but we're not completely sure about it. But in any case, I think that companies like Equiwatt and similar in the smart home tech sector, we are helping actually the grid and the market to be more heat pump smart grid ready to heat pump market.
Okay, thank you very much. Yeah, I would like to continue. I have other questions and other things we would be able to discuss, but unfortunately we have limited time. So I suggest we move to the second part of the webinar, but I hope you can stay for some more time and then listen also to the different projects that will be presented, and then maybe also engage in the second discussion, because it would be very interesting to connect also your experience with the practical examples of the projects. So hopefully you can stay a bit longer. Thank you, Atzin and Lindsay. As said, I suggest we move to the second part. So I suggest the other speakers of the project part switch on their cameras and join us. Now we will present 4 projects, and the first project is the Heat for Cool project, and this will be presented to us by Sma Tool. Serena works as project manager at EHPA, and she will present to us the Heat for Cool project, which is a Horizon 2020 funded project. She will also introduce us to the digitalization paper that we are working on at EHPA. So, Serena, the floor is yours to present this project.
Thank you. Unfortunately, okay, yeah, I was facing some issues, but now you should be able to see my presentation. Do you see it?
Yes.
Perfect.
Yep.
Perfect. Thank you very much. So good morning, everyone. I'm Sma Tool. As Jozefien said, I'm working at the HPA. Today, I present you some digitalization aspects of the Heat for Cool project, and then I will briefly introduce you a paper that we just submitted with EHPA and Heat for Cool about digitalization in the heating and cooling sector. Starting with the Heat for Cool project. So Heat for Cool is an European funded project in the framework of the Horizon 2020 program. We are 13 partners, and the goal of the project is to demonstrate easy to install energy efficient heating and cooling solution for building renovation. Okay, so the key technologies in this project are 6. So we have adsorption heat pump, we have solar PV and solar thermal collectors, we have self-correcting intelligent building energy management system, we use latent heat storage, and we also do heat recovery from sewage water. All these technologies are integrated and are tested in both on building and district level. Indeed, we have been testing these technologies in 4 demo sites in Europe in different climate areas. So we have demo sites in Valencia, Chorzów, Budapest, and Sofia. I would like to briefly introduce you the demo sites. So starting with the residential application, the first demo site we have is in Valencia. This is a quite big residential building with 12 apartments. In here, the technology system we adopted is a combination of solar thermal panels with an absorption heat pump and storage tanks. This system is providing hot water, heating and cooling to the 12 apartments. Then we also have the CBEMS, as I mentioned, is working at building energy management systems. These allowed an automated and non-intrusive adjustments on the heating and cooling set points in the apartments. If we move to the Sofia demo site, here we adopted a different system. Here we have solar PV panels on the roof, electric heat pump and PCM storage. In this building, we are providing heating to 3 apartments. And also in this residential application, we have been testing the CBEMS. In this case, it works more in generating recommendations to the tenants on the heating set points. In the third and last residential application we have in Chorzów, we adopted a similar system to Sofia. So we have also here solar PV, electric heat pump and PCM storage. providing heating to 11 apartments. And also here we have the CBAMs working in setting the best set points for the heating performances. And then in Budapest, we have a different demo site. In here, we are recovering heat from the sewage water, and we have a district heating and cooling circuit, which is providing heating and cooling for both historical and new buildings. What I would like to focus now is more on the digitalization aspect in the Heat for Cool project. And these aspects are related to the CBAMs, so the self-correcting intelligent building energy management system. So this technology has been provided by Vattenfall, which is one of the partners in the Heat for Cool project. And I would also like to thank Dimos because he supported me in making these slides for the CBAMs, since I'm not a technician. Regarding the CBAMs, so the CBAMs is installed, as we have seen, in all the residential demo sets we have, so in all the apartments we are testing, and is monitoring and collecting real-time data, both from the indoor conditions, so humidity, temperature, luminance, and also on the overall technology performances, as all the technologies are integrated in each demo site. Then the CBAMs provide a personalized comfort profile of each apartment, so of each end user, I would say. And so it collects the data from which are the set points and the temperature set by the tenants, and therefore what are their preferences and their comfort related to heating and cooling. Then the algorithm works in reading this information and matching them with demand side demand flexibility estimation and providing an optimization strategy. So how the end user behavior could be optimized, also matching an energy efficient behavior. And then it provides an automated control on the set points in each apartment. Now I would like to show you some data, so real data, and how the CBAMs is working in one of each demo site. In this case, we are talking about Valencia. As I said, here we are testing the CBAMs in 12 apartments. And the heating and cooling in these apartments are provided by fan coils. And the CBAM's infrastructure consists of individual heat meters located in each apartment. Then the communication gateway of the CBAMs is built on a Raspberry Pi board equipped with a Z-Wave Raspberry antenna, and we are using open source software. And then each tenant can control the temperatures in the apartments via smart thermostats. So as we can see from this slide, let's say the main two services provided by the CBAMs is the comfort profiling. So the algorithm estimates what are the comforts and discomforts probabilities, and the range temperatures set by the tenants. And then from these actions implemented by the tenants, match them also with the indoor and outdoor conditions. So the algorithm, so the CBAMs is also connected with a website in which it reads the information on the weather forecast. So it match what are the, let's say, behaviors, past behaviors and the past set points set by the tenants, and it match with the weather forecasting, just to provide an optimized set points for the, let's say, for the next week temperature that should be set in the apartments. So this is the automated set point control that it operates. Here we have an overview on some data from the 3 of the 12 apartments in Valencia, data collected from July to September. I would not go much in detail on this, but these are data that we analyzed in the project. So we looked at the green and red points that we have, and these are the comfort and discomfort action recorded by the tenants. And based on that, we can see what are the set points in which the range of set points that we can set to meet, let's say, the comfort for tenants. These are the data, let's say, a transcription from the graphs. If you have any technical questions for these CBAMs, I suggest you will see the email of Dimos at the end of this presentation. So I suggest for any very technical question to address to him. Then I would like also to invite you to the final online conference that we have for the Heat for Cool project. That is next week. So if you're interested to know more about the results of the project, you can join us next week. Then I would really like to briefly present you a white paper that we are going to publish today during this event. And will also be shared with you via email as post-event communication. So EHPA has written, with the support of Heat for Cool project, this white paper that is about digital revolution for the built environment, in which we discuss about digitalization, flexibility, and comfort in residential buildings. Of course, by providing a specific point of view from the heat pump industry. So we see digitalization as a huge support to the energy system integration, and we believe that digitalization can provide different benefits by increasing the use of renewable energies in residential buildings, by unleashed flexibility potential of end users, with an economic growth and technological leadership. Digitalization can also allow remote monitoring and management of the technologies installed in the residential building, and matching supply and demand at a more disaggregated level and to a closer real time. So of course, to, let's say, implement digitalization and flexibility in a residential building, first we need to have a smart building where the technologies installed are advanced and are integrated at a building level. Here we just have some icons of the possible futures and control we could have in a smart building. So the end user could control the heating, the illumination, cooling, water pressure. But of course, these are, let's say, basic standard, let's say, smart building. But of course, we could integrate way more actions. But focusing on heating and cooling, the management of integrated technologies, these allow increase of comfort for the end users, which, for example, if these technologies are managed by building energy management system, and also there is a tool, for example, like an app where the end user can check and regulate the performances, can simply how can I say, can simply regulate the heating and cooling comfort from the app, or for example, could turn on, let's say, the heat pump and activate the heating on the way home when when the person is going back to home. So these, of course, increase the comfort. It can also reduce energy consumption. It improves building efficiency. And it also allows predictive maintenance, because if you think that all these technologies are integrated themselves and you have a tool who monitors the technology performances, this is very useful because you can easily and quickly spotlight the flow and if something is going wrong with the technologies that you have in your house. And this will also allow renewable energy integration on a broader level. Here, this is just one of the graphs that we have in the paper. In this paper, by the way, we are both presenting technicalities, but also we are also providing policy overviews. So it's a really complete paper that I suggested to download and have a look. So in this graph, we provide an overview on what could be the heat pump position on different levels in a smart residential building. In the first box, we can see we have a very basic application. So we have a heat pump installed in a house with building energy management systems and connected to sensors. So the heat pump provides heating and cooling based on the comfort set by the sensors. Then in the second box, we have a combination with the heat pump, always with the building energy management system, sensors. Plus, we can imagine that the heat pump is also connected with PV panels installed in the house. So the heat pump will, let's say, will try to follow the curve of the electricity produced by the PV panels. And also the performances of these technologies will follow the weather forecasting. So we'll adapt, let's say, their flows by meeting the thermal comfort of the users. In the third box, we have the same structure of the one before, but here, for example, the heat pump will also be connected with the grid and will adopt a strategy and will connect to the grid by, if the end user has some flexible tariffs, to connect to the grid when it is more convenient for the tenants based on the tariffs of the grid. On the third box, we have the same structure, but we can add, for example, also the electric charge station in the building. So these are, let's say, another asset that is possible. And the fifth box comprehends all the assets, let's say, that we presented before, but with the fact that the building could be governed via the grid, integrated local supply and demand, and setting it into an overreaching context.
Serena, sorry to interrupt. I would like you to almost finish your presentation.
I'm finished. Yes, this was my last. So yeah, so these are our contacts, and just one comment: for the paper will be available both on EHPA and It4Cool website and social media, if you want to have a look. And that's
Thank you, Serena. Maybe if the paper is already on the website, can you put the link in the chat box so that people can
I'll do that.
Direct access. Okay, thank you. Then we move on to the next project, and that is the Sun People project. This will be presented by two people, David Bourguignon and Luc Meyer. So David, he's working for Aloen as a manager of the Sun People project, and he has more than 15 years of experience in applied R&D. And Luc Meyer, he is a sales manager by the Swiss software publisher Velo Solaris, and he's in charge of product management for the Polysun photovoltaic construction software, which is used in this project. So they will present to us the Sun People project in which heat pumps are combined with solar energy solutions, and they also use an energy service approach. So David and Luc, you have the floor.
So, yeah, thank you for the invitation. You should hear me and you should see my screen. Is that correct?
Works perfectly.
Okay, thank you. Yeah, thanks a lot also for David for inviting me here and give me a chance to present Vanbecelaere. I will take my time to to present our company, as I'm told that a lot of people in the EHPA are not similar with what we are doing. So basically we start a project lately with David to build up a simulation platform for the heating and cooling sector. And Vanbecelaere, from their part, we are delivering the simulation backend. So, and what is this? Also, we are a software manufacturing company from Switzerland. We consider ourselves at the moment as the market leader in the field of energy system simulation. We're based in Switzerland, which is actually a good moment for a heat pump as our government decided to electrify the heating and cooling market to completely to 2050. So we got a lot of possibilities to work with it at the moment. Worldwide, we are currently present in 40 countries, and we are got at the moment around 1,000 corporate customers which are using our Polyson software to planify and to simulate and to sell their heat pump or energy system. We are also offering services, consulting services for simulation. What you can see here, this is a Polyson simulation deck, and we are able to do a digital twin of the whole energy system, including heat pumps. And one of our main focus is also the heat pump. What we are doing, we can, out from this model, we are able to do a 1-year simulation with a resolution of 1 second. So within 30 minutes, a second of simulation work, you get out of this simple simulation desk of around 1 million time steps and 1 million calculations. So this digital twin afterwards enables you really to get the results you want. So we can here, for example, you heard a lot of examples today, like own consumption for energy yield. So this can be quickly calculated in every system. We saw different projects for energy, heat for cool, for example, those testing site could be also digitalized very fast in Polyson. But today, as we're talking about this this platform, this whole simulation platform is also available as an API, and this gives especially to some people project, this will give a huge success to it, as we can access this digital twin from a front end. And as you got this digital twin, we are able to transfer this data also. We can, for example, the customer in first hand can enter with very few data. Some people, for example, can build up a model and use this data afterwards and transfer it directly to, for a detailed planning. Maybe to get a better impression where this simulation backend is used already. At the moment, we got around 20 customers. One very interesting example, what you can also look up is, for example, our we delivered the simulation backend for the Hvac heat pump sizing tool, where the distribution partners of Hvac and the engineers of Hvac can decide really fast which heat pump, which controlling system is the best for the case. We heard also in this example, for example, we heard a lot about smart grid ready heat pump system. So of course, this function already can be implemented here. So we are able to modeling this heat pump, smart grid ready heat pump controllers, which is also very important for the next example where we delivered our simulation backend. This is the Sma Tool. This is a tool from the inverter manufacturer of photovoltaics in Germany. They got now a different approach. They we heard it shortly before from in the Heat4Cool project. Here you can they can optimize, self-optimize the heat pump consumption according to the photovoltaic production, and we got here Sma build it up planning tool and also a lead generating tool for their customers. So basically you can choose your inverter and combine it very quickly with a heat pump, and just check it out. It's a really nice product. And how this looks like for the Polyson API for such platforms and such applications. This is now more technical part. So basically, if you got you can access this API with a Java or C# library client. Also, we got Java and C# client libraries available. What we're using on the API itself, this is a Java Spring framework, and we got every user got the possibility to implement its own database in a MySQL. So basically, there are really common use technologies you can use here. We are also able to get a client library here, or the API is also accessible if needed over Python. So David, maybe you want to continue how you are intending to use our simulation engine in your project?
Yes, I will. I will share my screen now. Does it work?
Yeah, we see your screen, yes. And we hear you.
Thank you. So thank you, Luc. Thank you, Dan. Thank you, Serena, Irene, for the invitation. I'm going to present the Sun People project, but beyond that, I would like also to introduce the core topic of this talk, the reference simulation platform, in a second part. It's a common thinking we have in the Sun People project that could interest many people, in fact, beyond heat pumps in general. So Sun People is a project that has been funded by the Interreg French Channel England program. It's a small project. We have been we are on the last part of it. I'm going very fast on datasheet slides like this, but you will be able to have the full PDF of my presentation later. It's a project that is mostly driven by, I would say, public organizations, but there is also a small company, ASIO, working on training for thermal systems. And our general goal is to develop next generation heat energy services. We demonstrate them in Lorient, in France, and Plymouth, England. And we would like, at the very beginning of the project, to have a very solid and reliable tool to compare what we call the system business and impact cases of those sites. And therefore, we started working with Vanbecelaere Polyson. Of course, this project is also about involving stakeholders to, let's say, grow the market in Europe for such solutions. So very quickly, to try to give you an overview of what do we mean by a reference simulation platform. This is the current thinking we have and what we are currently developing in the project to design what we call site dashboards. So it's a series of modules, of components that are allowing us to develop simulation of first the energy scheme of a demonstration site on the left using Polysun, then an energy service that could be used on that site to provide certain features to the users. And then on the very right, the summary dashboard that a building owner or an energy service company could be interested in to make decisions on that site. So what is important to look at in this big picture of everything is the yellow boxes, the input interfaces. What is it important? Because we think that simulation platforms will work in the future through common interfaces. And I will put and describe that in more detail, put emphasis on that in more detail at the end of the presentation. It's a EU-wide trend and strategy for future IT. And this is very important to understand because I think the future of our energy systems will depend on that too. All right, so I will provide you with the link of this picture if you want later. Very quickly, again, a data sheet that is a lot of information, but what do we do in practice? We want the market to grow, we want users, we want customers to be aware of what we are doing. And
sorry,
so
David, your noise, there's a lot of a very bad connection. We don't hear you very well.
Okay, sorry for that.
Better again.
Do you hear me well? Do you hear me well? Yes, no? Okay.
Yes, now it's clear.
Let's move on. All right, sorry for that. I might have a strange connection issues. Okay, again. So Solar Cafe is about involving potential customers. It's called in English procurement exercise or a soft market testing. It's about making people aware of the benefits of solutions for them in 3 steps. So in the first event, we deal with system and impact cases of their buildings. So we are talking about energy and CO2 emissions. In the second event, we talk about the business case. So how it costs and what is exactly the difference between the options. And the third event, we make them aware of the potential, the benefits of energy services for them. So very quickly, it's a lot of potential solutions for people. It's just an example of system cases. Sorry, we have been able to compare with Vanbecelaere Polysun, and it's ranging from a plain old style gas boiler to a very high-end solar plus heat pump combination. And this is quite difficult to simulate, I would say, if you use your traditional Excel sheet style of design. Vanbecelaere Polysun provides us with very interesting summary of what's interesting in a system case with what I call the input-output energy system graph, where on the left you have the input energies that is either harvested on site or bought and imported for further use. And on the right, you have the actual energy that you are relying on for heating and cooling. And using such tool, we can have an overall comparison on all the buildings and using all system case of several key indicators. One of them is what we call the coefficient of overall performance. So basically, it's how much energy you get from how much energy you put in. And it's very clear that in this situation, the winning energy system was a combination of a heat pump, a solar thermal system, and a solar PV system with a COP over 4.5. So,
David, again, we cannot hear you.
Okay. Sorry. It's a bad day.
Sorry. No, we don't hear you.
Do you hear me well now?
No, it's there's a lot of yeah, cracking in
Here, do you hear me well? Do you hear me well?
Now, yes, yes.
I think this is an issue with my screen sharing, so I will keep it like that if you don't mind, okay? You see my screen? You see my slides?
Yes.
All right, okay, let's move on like that. Sorry for this. So the second indicator we are interested in is GHG emissions, of course, focusing on how much we save. In this graph, you can see that the winning system again is a combination of heat pump and solar, and it's very important to realize.
Sorry, David, we don't hear you.
Okay, sorry, I'm very, very sorry. I don't know what's going on. Okay. Should we stop there? Should we stop or should we move on?
Now it's better again. Maybe
should we move on?
And then if it's again going away, I will let you know.
Okay. I'm not in a work office, so sorry for that. I'm trying to to figure out what's best. Okay, so to conclude briefly, because it's a bit complicated apparently, there is obviously a need for a huge reduction in emissions using systems that is above 75% in greenhouse gas emissions. And we see on this graph that only the combination of heat pump and solar wins. And so to conclude my presentation on a let's say broadening of this topic to the general question of reference simulation, we believe that it's very important to have such systems in the future because we need to support complex decision making. And using data provided by the supply chain, using scientific validated models, we can compare effectively the system business and impact cases, either within the same site or between sites. And then using this data, we can make better decisions using forecasting, either at the design phase or even during the operations and maintenance phases. And that's a very important aspect of the simulation in the future. And for building owners and investors in general, it will mean an optimized CAPEX and OPEX. And of course, this has a lot of consequences from an economical point of view. And the second aspect I will like to emphasize on regarding reference simulation is that we need to scale up a market that is currently not necessarily sufficiently big to address our climate issues. We need also to scale up this market for truly efficient and innovative solutions. So using reference simulation, we can move from, I would call, a norm-based to a simulation-based approach. And this is very important because, in fact, currently, policies, government regulations are sometimes late regarding to what the technology and industry can deliver. And we need to have a kind of a scientific approach to procurement and level the playing field for innovative solutions. And only a simulation platform can deliver this. And in the end, the result of that will be to fix the dysfunctional aspects of the that are currently present in the market and scale up a healthier market.
Again, we don't hear you, so I suggest we conclude here.
Right.
Because
okay, sorry, I'm very sorry of that.
But I think we got a pretty good picture of what you wanted to say and the system you wanted to present. Thank you very much for that. I hope you can stay on the line and during the Q&A it will function again.
Yes.
Okay. Then I suggest we move to the next speaker, and that is Marco Barbagaleta. He will present to us the DreamPack project. Marco is Digital Solutions Business Area Manager and Board Member at STAM, which is a multidisciplinary engineering firm offering high-tech solutions. Marco has a Master of Science in Robotics Engineering, and he's specialized in software integration projects and digital strategy and open innovation. And also in the past, he has worked on software integration for utilities, delivering solutions to the top EU players in the energy sector. So he will tell us more about the DreamPack project, which aims at bridging the gap of communication between the grid and the market on the one side and then the buildings on the other side. So Marco, the floor is yours.
Thank you. Thank you very much, Jozefien. Thank you for the great introduction. First of all, can you all see my screen and hear me okay?
Yes, it's perfect. We see your screen and we hear you and see you as well.
Okay, beautiful, beautiful. So as you correctly mentioned today, I will tell you a little bit about the DreamPack project, which, as you can, let's say, assume from the acronym and the extended title, is focused on demand response. And how does it have to do with digitization? How does it have to do with heating and cooling and so on? Well, the answer is already included in the presentation given by the previous speakers, but in our cases, let's say, what's our take on this? So the aim of the DreamPack project is to enable the participation of small prosumers, so we're talking building level, in both implicit and explicit demand response programs within a future electricity market environment. So addressing, first of all, interoperability gaps along, let's say, the supply chain from the DSO to the building, and developing end-to-end solution, not only from a technical point of view, but also, let's say, from a business point of view. So this is fairly important, as you know, Europe aims to be, let's say, climate neutral by 2050. And since, you know, buildings take around 26%, so I said we're tackling building level, buildings take up to 26% of the energy demand, and about 70% of that is coming from heating and cooling. So I think that this picture that I'm drawing creates an information on how flexibility and demand response in particular is fundamental in order to allow a wider deployment of renewable energy sources, a wider deployment of smart appliances and so on, thus increasing the system flexibility. How and where are we doing this? So what we are doing is, like I said, we are developing an end-to-end solution, ICT-based solution that we are developing within five demonstrators. 4 are real demonstrator. 1 is in Spain, 1 is in France, 1 is in Germany, and 1 is in Cyprus, and 1 is, let's say, a pre-piloting testing in Greece. What we're doing here is we are developing an ICT infrastructure to enable services and devices interoperability among different stakeholders, from the DSO to the prosumer going through the utility, which Jozefien mentioned. And what we want to do is we want to allow stakeholders to take part into implicit demand response based on day-ahead dynamic tariffs, so price-driven, energy price-driven, and explicit demand response services, so based on signals from the grid. How we are doing this? From, let's say, a functional point of view, we are going on flexibility resources within residential, tertiary buildings and district-level energy resources. And the scope is to provide an open, standard-based, and when we are talking about demand response, standard is kind of a buzzword that is thankfully coming to reality, to enhance building management intelligence for enabling end-to-end communication between the building and the energy distributors and aggregators, in order to publish the information about the flexibility potential of a building or of group of buildings, so that can be used to increase the resilience of the grid. Concerning the ICT framework, it comprises 2 main service layers, which I'm going to get a little more details about in a second, which are related to interoperability and automation. Demand response programs require smart energy metering and control of the building assets. So this is also, let's say, a big chunk of the DreamPact framework, which hopefully you can see properly here. As you can see, the energy demand management framework here in the middle includes, like I said, the building interoperability layer, which takes care of allowing different components with the, let's say, different languages, we could say, communicate. And also the building supervisory and automation layer, which basically controls the energy management, the energy systems of the buildings, and based on data analytics, AI, and forecasting, also based on physics, allows to extract the flexibility potential of different buildings and to present this information to the stakeholders that are then enabled to use it and take decision. Here. About these components within the frameworks that I have very quickly described, what has been done up to now? So, like I said, interoperability is a big component of the tool, mostly because demand response in general, but smart metering in particular, and all of the ingredients that compose demand response are not standardized or are becoming standardized. But in the meanwhile, if we want to be to start delivering value, we need to allow different components to communicate efficiently. The ICT backbone for the connectivity of DSO, aggregator, the platform, and the asset is complete, which means that within the demonstration scenarios and within scenarios that use the same kind of technologies, we are able to have end-to-end communication. Then one of the technical partners of the project, Hypertech, developed an energy management system, smart boxes, and local IoT monitoring control systems. So this is covering the central part about the building supervisory and automation layer, but also the actuation and the monitoring within the demonstrators. UC-Y, which is the University of Cyprus, is developing a platform to interface with commercial BMS, so building energy management systems. And the part on the bottom here is related to more in detail results about what's been done, which is an OpenADR communication. OpenADR, as you probably know, is one of the existing standards regarding communication for demand response events. Extension of the current VT and VN, so virtual top node and virtual end node, regarding the EI report, and development of several data-driven value-added software regarding flexibility, predictive maintenance, but also comfort. I saw within the questions previously that comfort was one of the main worries, especially if we're talking heat pumps, because you know, shifting the demand in terms of heating and cooling or hot water might mean that there is a lack of comfort, and this might mean that there might be a prejudice from the consumer to actually use a certain solution or to leave the control of his or her buildings to a machine if they fear that they're going to lose solution. So here we're talking about, as you can see, the components that allow the different elements of the system to communicate with, let's say, an IoT-based communication, but also the data layer that allows to collect all this information and make it available to the intelligence, which is a software platform that allows to model and forecast different elements related to building demand, available flexibility, and predictive maintenance and users' comfort. Like I think Atzin, but also Serena mentioned during the previous talks, that of course, it's none of that, it might be the best technology ever, but none of this is going to be deployed, used, or scaled if there is no sustainability from a business point of view. So this is also why a big chunk of the work performed within the DreamPack project is revolving around creating innovative services offerings and business models. So I will just very quickly go through them. So here you can see in the first one, the what we call the integrated supplier and aggregator. So it allows suppliers to optimize the balance position of their portfolio by applying dynamic pricing scheme, and it provides flexibility to the DSO. So what you see here, the BRP, is what is called the balance responsible parties, and they are basically a man in the middle that allows a supplier to talk to producer, that to talk to DSO and exchange information about flexibility and give back to prosumers cost savings due to dynamic pricing. The second part is if we have the second drawing here is if we have an independent aggregator that interfaces let's say the BRP, so the balance responsible party, but also the DSO and the TSO directly to the prosumers, and allows to exchange flexibility in change of money, let's say, both saving but also incentives. And this allows to dissociate energy supply and flexibility services while providing flexibility to the DSO. And the last service offering and business model that was, let's say, brainstormed within the project is what we call the FLESCO, so flexibility service company. So there is a service provider that takes care of load shifting behind the meter and allows to maximize prosumers' benefit from, let's say, a dynamic and time of use pricing schemes. So it's like we have for the ESCOs that basically take the burden of managing energy for assets or sets of assets and basically build the margin of saving or of earning on that. Here we plan to do the same within both direct and indirect demand response for flexibility service companies. So this was just a glimpse on the DreamPack project. If you have any question, I would be glad to respond, and I hope you managed to follow through.
Thank you very much, Marco, for this interesting presentation. We will move immediately to the last presentation, which is the story project, which will be presented to us by Johan van Baal, project manager and activity leader at Vito. So Johan has worked on several regional, national and European projects, both for governments and for the industry on cooling and heating systems. He's currently activity leader for the research group on conversion systems, so heat pumps, heat exchangers, and ORC, thermal energy storage, and district heating and cooling networks at Vito here in Belgium. He's an expert in different European projects, and he is also an inventor of several of the Vito patents. And he will present to us the story project, which demonstrates, evaluates innovative approaches for energy storage systems at different demonstration cases. So Johan, you have the floor.
Okay, thank you. I hope you can all see my screen. I hope that it's, I would like to present, in fact, in short, the story project. Thank you also for the kind introduction, Jozefien. And I'd like to thank also European Heat Pump Association for giving me the opportunity. First, a short introduction on Vito Energyville. So Vito is a research institute. We are collaborating with different institutes like the University of Leuven, IMEC, and also the University of Hasselt within the Energyville collaboration framework. There we do research all related to energy, materials and components, energy networks, storage, strategy and markets, and also buildings and districts. And our research, or from my team, the research is related to thermal networks, thermal energy storage, and also energy conversion technologies, like also heat pumps. I would like to give first a brief introduction towards the story project, an Horizon 2020 project, the objectives of this project, and also the demonstration of different types of energy storage technologies. And then at the latest part of my presentation, I will give also an overview of the method for energy content determination of water storage tanks that we further researched and developed and demonstrated also within this project. First, some general information about the STORY project. The STORY project consists of 18 partners all over Europe. The coordinator of the project was the Research Institute in Finland, VTT, and the technical coordination has been done by Think-E, a Belgian company. The project itself had a duration of 66 months, and it's already finished last year. And the total budget was around 16 million euro. Here you see an overview of the different partners that participated in the project. So it consists of different research companies, universities, also SMEs, and also companies delivering certain technology relevant for energy storage in general. The project itself had different objectives. It was important, in fact, to demonstrate at the end and evaluate new approaches for energy storage systems. It's not only electrical energy storage, but also related to thermal energy storage. And in fact, we want to demonstrate the use of these technologies for being used in the electricity grid in order to, for instance, increase the percentage of self-supply or self-consumption of electricity. And next, we worked also on innovation and business models for deployment of energy storage at the local level. I will go shortly through the different demonstration projects. The demonstration projects were all around Europe, so both in the north and the south. The first demonstration project was here in Belgium, in Oud-Heverlee. It was the building of one of the partners that is renovated and brought to a very low energy consuming level. And in this dwelling, or in this in this renovated dwelling, we integrated all the new technologies like a heat pump, smart controlled heat pump connected to a borehole thermal energy storage systems. They have also an electrical vehicle, so smart charging is also demonstrated here. Different types of PV and thermal systems. And then also some technologies related to thermal energy storage, so hot water tanks, in order to make systems more flexible. Not only this one dwelling in Oud-Heverlee, but in fact also the neighborhood, the street was also participating in this project. In fact, this street had a very weak grid connection, and that has given some challenges towards the DSO and also towards the tension in the network itself, due to the fact that more and more houses were equipped with PV. And in this neighborhood, different technologies have been demonstrated. And for the first time in Flanders, we demonstrated also a neighborhood battery. So it's a battery that is used for different houses, not only for one house. There was also demonstration of a fuel cell and also smart controlled heat pumps. And some of the buildings were also equipped with electrical and thermal energy storage. The next project, the next demonstration project is a demonstration project in the south of Europe, in Spain, where an industrial facility has a lot of PV installed on the roof. And they want to increase the self-consumption of this PV because at this moment it was not that self-consumed. And for that, they installed a battery. And you see here also the technical information about this battery. So 50 kilowatt power and 200 kilowatt hour of energy storage capacity, in order to reduce the peak power and also to increase the self-consumption of PV. The next demonstration project was in Northern Ireland. There was a lot of windmills that were installed there. And in order to avoid a new substation to be installed, a new type of energy storage technology has been developed. in the project for based on compressed air energy storage. So it's not batteries, but it was based on compressed air energy storage with a larger amount of energy that could be stored in order to balance better the local grid in this area in Northern Ireland. The next one is a project in Slovenia. Also a battery that was installed with a quite high capacity at the substation, because at this rural area a lot of PV has been installed and there were some issues with the grid and the substation, and in order to increase the self-consumption of the locally produced PV and to avoid that the substation had to be enlarged due to this PV that has been installed, also a battery has been installed to store the energy of the PV if needed and to use it at later moments. Then we have also a demonstration project here in Belgium in an SME zone. It's a company, a construction company located in Ole. And they had, before the project, an old wood-fired boiler where they burned the waste wood they had within the manufacturing processes. And the aim within this project was to install a new wood-fired boiler, including also an organic Rankine cycle to produce electricity at local level to be used in the SME zone and to be increased with flexibility by adding also thermal energy storage tanks in order to control the ORC in a more flexible way and to reduce the peaks in the heat demand. Here you see a small scheme of this installation with, on the left side, the waste wood burner with a capacity of 1.6 megawatt that is delivering heat to an organic Rankine cycle. And also the waste heat of this ORC is used for office heating and also for some of the processes. This waste heat has a temperature level of 45 degrees, so it's quite low. Due to the fact that there are also buildings and processes that needed high temperature heat, there's also a network operated at 90 degrees in order to supply the heat for these consumers. In order to make the whole system more flexible, you can see also there are different hot water tanks installed with a total capacity of 20 cubic meter and 50 cubic meter. All the results are also public of this demonstration project, so I would like to give you the links also to the website of this story project. And a very interesting brochure is the demonstration booklet, where you can find all the results of these different demonstration sites, including also the sites here in Belgium. Next to that, we have also made a very nice document related to the key performance indicators for thermal and electrical storage. So you can see here also the links towards these documents, so they are freely available. And if you want to know more about this project, please look at these links. Now I come to the second part of the presentation. It's related to the energy content of water tanks. That's quite important. Why is it needed? There are a lot of tanks that are already equipped with sensors. For instance, you have the electrical hot water heaters. They have normally just only one sensor, and it's only used to switch on or switch off the electrical resistor. It works perfectly, but the disadvantage, in fact, is that you cannot use only one temperature sensor in order to know what's the energy content of the storage tank, because you measure only the temperature at a certain height and you don't have an idea about the temperature above or below. From the other side, you have also the larger scale water storage tanks, for instance, CHPs that are connected to these storage tanks and delivering heat towards a greenhouse. These tanks are mostly equipped with a lot of sensors, 10 or 20 sensors, all along the height of the tank. That's of course very interesting because you have a very good idea of the temperature level at the different layers in the tank. But of course, there is a high investment cost for these temperature sensors, and in some cases also a maintenance cost afterwards. So the idea within this project was to develop, in fact, a combination of a model of the tank combined with a limited number of sensors along the height of the tank in order to determine the energy content of the tank. So without using a lot of sensors, but by combining a model with a limited number of temperature sensors. This information, this data is then sent towards the system working in the cloud. This data is then used in the model, and this model is then defining the state of charge or the energy content of the storage tank, and that information is then sent to the control unit. In fact, we start with measuring the tank loading, unloading in different cycles and so on, with a lot of temperature sensors, a lot of flow meters, in order to make the model more detailed and in order to fit the parameters of the model. Based on that, so we make the model, the parameters have been fitted within the way that we do it. And then next, we start to eliminate certain temperature sensors, certain flow meters. We want, in fact, to use this method without any flow meter. We have defined a method in order to select those temperature sensors that are most interesting for a certain type of tank. So in this case, 3 temperature sensors are left over. Then we combine this with a model, and the model is running in the cloud. And based on the data we get from these sensors, we determine the state of charge or the energy content of this water storage tank that can then be further used, for instance, to control a heat pump. It's not only some theoretical work we have done. Our method is also used within the project for one of the heat pumps that has been installed in the project, in the demonstration project in Hydronic, where an aggregator is using our data in order to control the heat pump in a more smarter way, to increase self-consumption, to reduce peaks in the grid itself, and to combine it also with other flexibility options. We are also integrating our state of charge method in our own building energy management system that we are developing, including also PV, heat pumps, smart battery, and smart charged electrical vehicles, and so on. We are also integrating this in our storm district heating network controller that is used to control district heating networks using the flexibility within the network in order to offer it towards the different users of the network, towards the operator of the network. So it's also further integrated in the products that we are developing in our research institute. And so I come to the end of my presentation, because I see that there's not that much time. So here you see also my contact details if you want to know more about the STORY project or about this energy content determination method. You can contact me or my colleague Erik de Schutter. So I would like to thank you all for attending.
Thank you very much, Johan. Indeed, the time is running, but let's try to have a fruitful discussion anyways. I see that in the chat we have received just one question. So someone is asking, what about cybersecurity issues? This can be a severe roadblocker. So Serena mentioned it in the white paper, but it seems that the EU has a delay in terms of legislation on cybersecurity issues. So if any of you has encountered these type of issues or sees, what are regulatory barriers concerning cybersecurity, please enlighten us. Any of you would like to answer this question or has encountered cybersecurity issues during their projects?
I will try to take it. I think that overall, not only cybersecurity but data governance, absolutely, it's one of the hot topics. And especially if you cover, let's say, the wide spectrum of stakeholders involved, from transmission towards the end user, what you see is usually that towards the end, so towards the users and prosumers, getting information or installing devices that might be unsafe, quote unquote, is not perceived as risky, because we have, you know, we have Alexa, we have 1,000 of apps that we don't know who developed and so on. Well, as you're moving up, so towards DSOs, retailers, but also producers, it's hotter and hotter. The thing is, there is a little bit of, I wouldn't say delay, so I partially agree with Marco Portale, who posted the question. I would say that we need events such as this one and such as all the other events to create alignment between different projects, because there are projects focusing on, let's say, the security of the energy system and on the electricity system within smart grids. There are projects that tackle just that. There are projects that tackle just demand response. And I think that creating links within these projects is what allows to move forward rather than, you know, have a top-down approach with regulation and so on.
Okay, thank you.
Maybe, Jozefien, I would like to add something to that. I think cybersecurity is also a problem of the design of our systems. If we build systems that are completely locked in, that are completely interdependent, that have no flexibility or some wobbling possibilities, the systems are very fragile. So it's not only cybersecurity, it's how do we develop our systems. And it's very important to understand that if we start developing an energy system at the EU level that is completely integrated from the very little scale to the very large scale, it's kind of fragile. We need to have more independence, we need to have more local storage of energy and so on, that will allow some more flexibility and more resilience to the system. So that's what I wanted to explain with my data sheet on Gaia X. Gaia X is a project. I can maybe try to briefly share my screen. It's a project that is really about that. It's really about building the future cloud infrastructure for all data in Europe that is not based on a centralized system, but rather on a component-based system with interfaces for distributing data. So it's a distributed infrastructure, and this is very important for cybersecurity.
Okay, thank you. I don't have a but I think the explanation was clear. If there's no other comments on this question, I will just briefly ask one question per project and then a more general reflection. So first of all, to Serena on the Heat4Cool project. So the Heat4Cool project is almost ending. Could you tell us a bit more about the project results?
Yes, thank you. So the Heat4Cool project is ending in 3 weeks from now. So we are now actually making a final leaflet in which we are presenting all the monitoring data from the past years of testing. For the time being, I don't have the results in my hands, since I was saying we are still gathering this data and making the leaflet, but I would like to suggest to all the people that are interested in the Heat4Cool project to follow up on this by looking at the website, and these results will also be officially presented next week on the 17th of March at the final event.
Okay, thanks, Serena. So then on the Sun People project, David and Luc, so your vision of this simulation platform or the simulation-based approach, what do you see? What is currently the main barrier or the main obstacle to really having this as the standard approach?
Okay, I think that this is under construction. We need to gather all the supply chain, in particular the manufacturers, on this idea that we cannot move forward together and strengthen together the offering without such platforms. And so Vanbecelaere, and maybe Luc, you can complement my answer to that, is really started that a long time ago. and it's becoming more and more prevalent, but there are still manufacturers who do not know about Vanbecelaere's polyson at all. There are still systems that you cannot simulate. There are many engineering studios who do not use such high performance simulation and rather rely on Excel sheets. And this is very limitative. And yeah, it's market awareness, the main barrier for the moment.
Okay.
Yeah, maybe I can to add that the moment the biggest challenge for using dynamic simulation in planning is really in some markets dynamic simulation is not regulated yet, so our results will not be accountable, for example, on a state level to get subsidizes and stuff, but in markets as Germany, Switzerland, Austria, energy dynamic simulation approach is considered is accepted by the governments, and so I think as this is an issue we're facing now in France and UK, as we are which prevents using simulation and for planning projects.
Okay, thank you. And then a question to Marco. So do you think that digitalization is adding or is reducing the complexity to regulatory, social and technical transition towards greener HVAC technologies?
I think in a way it's adding complexity to reduce it, and by that what I mean is that in the previous speaker was mentioning how to the key barriers, and of course it's plural, so it's more than one barrier, because you have the market awareness, you have, like I mentioned, interoperability, you have cybersecurity, like Nikolai from the question mentioned, you have sustainability, like Atzin mentioned. So digitization is adding all of these challenges, but in the end is obviously going to reduce the complexity, because it's going to digitally enable an easier, smoother and more resilient management of the energy system. And by that, I would also like to stress that one of the key challenges in terms of the technical challenges is related to interoperability, and that is, having different devices, different systems communicate, making them speak the same language. And I think this also relates to the people and the stakeholders, and I don't mean let's say English, French, Spanish, but the same language in terms of understanding the value and the path that needs to be covered. And with this regard, I think that one of the initiatives such as this one, but also bigger initiatives, bigger scale initiatives such as the European Digital Innovation Hubs initiatives and so on, is creating clusters of values, competencies, and technologies that can focus on specific sectors. So I hope this was a response.
Yeah, thank you. That's very clear. And then I would go to Johan. You mentioned the story project, and my question would be: do you have research results on the combination of heat pumps and electrical storage for households?
So in fact, the story project was focusing on the demonstration of electrical and thermal energy storage and the added value to the grid. Mm-hmm. So in one of the demonstration project, there was a combination of electrical storage with batteries, also an electrical charging, electrical vehicle with smart charging. So there it was also foreseen to demonstrate also the combination with the heat pump that was installed there. So for that, I think it could be a nice combination, electrical storage and heat pumps. The only thing is, of course, that with an electrical storage based on a battery, you cannot overcome the heat demand in the winter months and the extra sun that you have during the summer months. So it's only for optimization during hours, during days, but it's not feasible, of course, to use the electrical battery to store in summer months and to use it in the winter months. So that's, of course, clear, so that could not be demonstrated. But the smart use of a battery combined with the heat pump, that was also one of the results within the project. Of course, also combined with other appliances, other smart appliances, other systems that are also connected towards the grid, including then the heat pump.
Okay, thank you. Then I have a broader question actually to all of you. So we have seen many innovative solutions to deploy the digitalization of the heating and cooling sector. But could you address like one main barrier, and actually more important, one key advice you would give to policymakers to really enable this to become a standardized solution? I know, for example, Marco has talked about these digital innovation hubs, also that you need to have a good business model, these type of things. But do you also see regulatory barriers where really policymakers could make an important change to, if I look at the different examples of today, for example, to make these CBAMs and this comfort profiling a standardized large-scale deployed solution? Also the simulation-based approach to have this widely spread. Then also on this standardized communication that Marco was talking about, also to have this as a standard in place. And then also the storage possibilities and the connection to the different technologies that is used in the storage projects to have this standardized. Maybe I can speak from my personal situation. So my family, we are renovating a house here in Brussels. It's an old house with a gas heating system that we are replacing with a heat pump. So we are still in the phase of getting all the approvals from the commune and so on. We have contacted the heat pump installer, but we have not been informed about, is this heat pump going to be connected to the other devices in the house? How will this be able to respond to flexible tariffs? Will this be connected to other houses in the streets, or maybe to a larger region, or to the grid in general? So all these solutions, they are not standardized at this moment. Also not the interconnection, for example, if we would have PV on the roof and these type of things. So what do you see as a main advice to regulators to really have this at large scale deployed and standardized offered when people, for example, renovate their heating system? Maybe Serena first.
Yes. Yes, I agree with you, Jozefien. I think now for the end users, like yourself in your example, it's really hard to get to know all the possibilities available. So I think first, apart from the, let's say, policy efforts needed from policymakers regarding standardization, what is needed is to reach end users and disseminate about the possibilities as the ones that we have seen today from the project, what is possible to do. So how can you make your home a smart home and with all the technologies integrated, and what kind of building energy management system you can have, which kind of services you can get from it. So I think we really need to get in contact with the end users to share information about these possibilities, and also to stress more about demand side flexibility, because I think there is quite a good lack of information on the end user level. So we need to work more on this. And for this reason, dissemination events like this online conference and others events are needed, because I feel that end users are a bit unaware of all the options available in the market.
Okay, and then David or Luc?
Yes, I would let Luc maybe elaborate on that, but I think there is a missing link in the policy framework right now. There is nothing about simulation. We really need to consider simulation as a way to confirm the validity of the design, for example. And for customers, it's very important right now to have a better, understanding of what's going on, and trust. To build trust is really important. And I think science-based simulation is really there to make things more understandable for customers and more reliable also for the entire supply chain. So a policy regarding simulation would be very, very welcome. Luc, maybe you want to say something about that?
Yeah, of course. Yeah, thanks, David. Yeah, I mean, it's the main reason why, for example, Polyson exists is a huge load of information, which is even confusing for engineers building up the technology out. And at the moment present yet, there's no validated tool for accessible for the end user, yeah, which makes it possible to compare his system. And yeah, he's still depending on companies giving this information, and there's now a neutral platform where he can effectively compare system in its region. Yeah, thanks.
Okay, Marco.
So I can just, of course, agree with what's been said until now. I really think that reaching out to end user, to stakeholders in general, is definitely the key. I would also like to stress the fact that sometimes I think that the needed change is more into mindset rather than in introducing technologies, best practices, and governance. So I hear a lot of time ways of saying, how do we introduce new technologies to smart grid, or how do we introduce new energy management system, new business models? While I think that the more effective question is, how do we change, how do we transform the existing technologies, business models, and policies to make sure that us tomorrow are go through a smooth transition? Because of course we cannot expect the digital transformation of smart grids, energy systems to be digital. One day it's off and the following day it's on. It's going to be a continuous process. And so thinking what's new without thinking how does it transform what's old, I think that's definitely a shortcoming.
Okay, thank you. And then Johan.
Yeah, I agree also with the previous speakers about their answer. What I see also for these new technologies at this moment, and that's also my personal view, if you do also the business calculation of these new technologies, like for instance a heat pump or a battery, it's not that easy to get it right, especially here in Flanders. There is quite a huge difference in price between electricity and, for instance, natural gas or oil. And that makes it not that easy for a heat pump or for a battery in order to get a good business case that can also convince a household to invest in a heat pump, because at this moment natural gas is still quite cheap compared to the electricity, and that can also have an impact in the end. So people are in a lot of cases very interested to install new technologies, but then they make the calculation based on the information they gather, or they read things, and then it's sometimes difficult to get them buying the new technology, because it's not that easy to get it right. And that's also makes it a bit more difficult for some of these renewable technologies and electrical and thermal storage to be integrated. So it's next to what is already mentioned. I think that's also an issue that I see at this moment when we do some calculations related to these new technologies.
Thank you, Johan. Yes, I can fully agree with that. I know the Flemish situation very well, but also in other countries this is an issue. So to conclude a bit, we can say that, yeah, there are all these new technologies. They are very interesting. We need to reach the consumer, but indeed, it often comes down also to the cost and to the price. And there, I think, yeah, regulation can do quite a lot. So what Johan just mentioned, that electricity is typically burdened with taxes and levies to an extent that marginalizes the cost-saving opportunities from demand-side flexibility, for example. So yeah, this is something that we are also at EHPA working on. There's a revision of the energy taxation directive, among others. They are looking at carbon pricing to extend the ETS system. So these are all things that maybe, yeah, regulators can tackle, and that could also more open the possibilities. Once this flexibility is more rewarded, all these solutions will probably will be deployed easier at a larger scale. So thank you very much, everyone. We run already a bit out of time, so I will not longer keep you from having your lunch. We will send everyone also the presentations of today, and there is also a recording, so that will also be accessible to everyone. Yeah, thank you very much. This was very interesting, and I hope to stay in touch and hear you all soon. Bye.